Now we have the waveforms of phase voltages, that is VAN, VBN and VCN, as well as the line-to-line voltages VAB, VBC and VCA. If the alpha is 0, which is nothing but there is no control, then the input voltage is going to appear across the load. And for alpha equal to 60 degrees and 150 degrees, you can find the waveforms in any textbook. Let us draw waveforms for alpha equal to 90 degrees. This comes under the combination of second one, that is nothing but one thyristor, two diodes or one diode may operate at any time. Thyristor 1 is triggered at 90 degrees. This is T1. And similarly, then thyristor T3 will be triggered at 210 degrees. Thyristor T5 will trigger. T1 is going to conduct until the next thyristor turns on, or the current flowing through the thyristor T1 will become 0. Now, let us check. VAN is available until 150 degrees. So, thyristor T1 is going to conduct until 150 degrees. Then after 150 degrees, the thyristor T2 is not going to trigger. T2 is going to trigger at 210 degrees. In this period, that is 150 to 210 degrees, the load voltage is going to depend upon the voltage VCA, which is not equal to 0 between 150 and 210. So, between 150 and 210, we can keep the thyristor T1 in on position, since the current flowing through the thyristor T1 is not equal to 0. So, until 210 degrees, T1 is going to conduct. So this is a T1. Now, T2 is going to start conduct from 210 degrees, continue to conduct up to 270. After that, this is T5, sorry, and this is T3. And T5 is not turned on at 270, but it is turned on after 90 degrees. So it is at 330. Meanwhile, the current still goes to flow through the T3. So this is T3 period. Now T5 up to 360, T5 will be there, and after that also T5 will be there until T1 is there. So this is a T5 period, right? The cycle is going to repeat after 360 degrees. Now, what about the return paths, the diodes? When T1 is turned on, there is no chance of turning on the T4. T4 will turn on when the T1 is off. The conduction period of D4 is 180 degrees. So from here to 180 degrees. D4. Now, similarly, D2 will be on when T5 is not in on position. So, after that, 180 degrees. D2 tab. What about the D6 here? D6. D6. Now, let us try to draw VAN, which is nothing but the load voltage between 0 and 360. Now, if you observe this, here between 0 to 13, T5, D4 is turned on. Here T5, D6 is turned on. T5, D6. Here also we have the D6. And here D6, T1, D2. Here D6, T1, D2. Here T1, D2, T1, D2. Here T3, D4, D2, T3, D4, D2, T3, D4, T3, D4, D6, T5 and D4. So you can see the combinations of 3 devices or 2 devices are working. You can consider from here, since alpha is 90 degrees, this is alpha 90 degrees here. Now when you consider here D6, T1 and D2 are in operation, that is 3 devices are in operation, which is nothing but the output voltage is going to depend upon the input phase voltage. The T1 is the corresponding to VAN, so VAN is going to present between this and this, and between this and this the VAN is coming down. Here T1 and D2 are present, which is nothing but 2 devices are in operation. Then the voltage across the load is equal to half of the line-to-line voltage corresponding to the 2 devices, that is T1 and D2. T1 is connected to VA and D2 is connected to VCN. So half of the VCA, half of this part. This is VCA by 2. Then here T3, D4 and D2 are connected. 3 devices are connected here. And T3, D4. Half of line to line voltage between VBC. This is VBC half. Again, 3 devices are conducting, corresponding phase voltage VAN. So this is our output of the phase VAN. So 3 devices VAN. This is VAC by 2. This is again VAN. This is VAB by 2. This is VAN. We'll try to draw for VBN also. T3 is going to start at 210 and 3 devices are conducting until the next 6 degrees. So it's going to follow for VBN. This is VBN. From 270, T3 and D4 only, 2 devices, and T3 is connected to VBN and D4 VAB. So half of the VAB. This is VAB by 2. 3 devices are connected VBN. And further if you go, then 2 devices will be connected. After this, VBC by 2. Finally, we'll try to draw VCN. VCN is going to start at 330 and it's going to follow VCN. This is also VCN. This is VBC half. Then VCN. This is VCA by 2. This is VCN. So these are the load phase voltages. In case of alpha equal to 60 and 150, you can refer on the textbooks. This is for alpha equal to 90 degrees. So when you are able to find out the devices connected at that particular pitch interval, then you can easily draw these waveforms. Since when 3 devices are operating, the complete phase voltage is going to appear. When 2 devices are operating, half of the line to line voltage corresponding to that particular 2 devices you can draw like this.